Let's look at number 9 next. Notice again I have two natural log terms on this side. So what we're going to do is we're going to combine them into one natural log. So I'm going to write it as the natural log. And if I'm adding between two logarithm terms, I multiply these. That was one of the properties with logarithms. So I really have 4x squared multiplied by 9, which is 36x squared. And that's equal to 4. Now again, I only have a natural log in this case, but a log term on the left side. So I kind of want to think of it in exponential form. This is base e because it's natural log. So I want to say that this 36x squared is equal to the base, which is base e, to this power on e, so e to the 4th. Now you're going to solve for x, so my next step is divide by 36. So I get x squared is equal to, so now on your calculator you got to find that E button, which is usually above the natural log button with a second or a shift key. We're going to take E and we're going to raise it to the 4th power, hit equals, and then whatever that is we want to divide by 36. And if you go ahead and do the calculator work for that, well, E to the 4th I guess is about 54.5982, and then I'll just leave it as divide by 36. So now let's go ahead and divide that. So if I take that 54.5982 and divide by 36, I get about 1.5166. Now I'm going to do the square root of both sides. So x equals positive and negative. Take the square root of that 1.5166, and it's about 1.2315, positive and negative. And again, this one, both of those do check out, because if I went back and put either the positive or negative in there, I would be squaring them, which would create a positive, multiplying by 4, so I'd be taking the natural log of a positive. Because again, all of those things we did earlier with common log or log logs apply to natural logs too, and so they got to check out. Sometimes you can have an extraneous solution. Ahead here and go to number 25. So if I go to 25, now one thing I'm going to have you write down in your notes, if this is true, and these are called inverses of each other, if I have the natural log of e to some power of x, well, that is equivalent to x. They are kind of inverses of each other. So I basically end up with getting whatever this is when I do this. And here's the reason for that. If I had the ln in base e of e to the x equals something, well, I would do this e to the x is equal to e to what power? You know, this base to that power, well, it'd be an x in there. And that's kind of the reason. So what we do to solve any equations that have this base e in them is we take natural logs of both sides. So on 25 here, what I'm going to do is I'm going to take the natural log of e to the x equals, and I got to do it on both sides just like we did with common logs in the last section, the natural log of 87. Now, this kind of just cancels out. So that power doesn't come down in front, that just is inverses of each other and leaves me with x is equal to the natural log of 87. Now you find that ln button on your calculator, you do the natural log of 87, and we're going to the nearest 10,000th, which is 4 decimal places. So it's 4.4659 approximately for number 25.